Hey, welcome everybody. We've got a bunch of material to cover, so we'll get started right away. So this session is called Writing Gradle Build Scripts in Kotlin. You guys have been hearing a lot about Kotlin probably over the last few weeks. If you follow Gradle, obviously in both of the keynotes we've been mentioning this. How many were at Dimitri's keynote this morning? Yeah, okay, most of us, right? So that was a nice segue because he talked about a lot of the language features of Kotlin itself, and here we're going to go into more depth about how we're using them in Gradle itself. And I want to start by talking about some principles, like what led us to this, what's some of the background that got us to where we are now, and what's driving the process as we evolve it. So if we just go back to the beginning and ask the question, what would a perfect Gradle scripting front end or a perfect Gradle scripting language look like? What characteristics, what properties would it have? Well, it would be richly expressive. It would allow you to express the concepts of your own application's domain and so forth, like all the reasons that we've been working with a DSL all this time, so it would preserve all of that. It would be deeply tooling friendly. It would allow you to be richly expressive, but also get auto-completion and all of the things that you expect from modern day development with your tools. It would be fluid and readable, again, some of the properties that we expect from DSLs. It would be highly performant in as many cases as possible. It would be concise, and it would allow for a declarative approach while still allowing you to drop down and do imperative things. Okay, it would also, ideally, the ideal Gradle scripting front end would take advantage of your existing skills and your existing knowledge. So like as a software developer, many of us are probably build masters. Some of us are probably, our jobs are actually, running the build teams for companies. But at heart, we're all software developers. We've all done application development, very likely. And when we're doing application development, whether it's a web app or some systems level programming, right, we have this rich set of tools in front of us with IDEA, this rich set of libraries, rich set of techniques, and so on, that we know very well and give us kind of godlike powers. But when we get into the build script, right, whether that build script is Make or Maven or Java or whatever, all those techniques and all that rich tooling, it often isn't there or isn't there in the way that we expect it when we're working on an application. So this is what we mean when we say that it would take full advantage of your existing skills and knowledge in the rest of the code that you write and would apply it to the build script. So you'd get to use all the tooling. You get to use a language that you're familiar with or a language that's rich, maybe the same language that you use in your application, you would use in your build script. That would be ideal. That would be amazing if it worked out without compromise anyway. It would allow you to use some of the same patterns and techniques, right? Refactoring, just all the things that we've learned and mastered over the years at the application level, bringing that to the build level. Because the thing is, right, builds are just as complex, just as rich, if not more, than the applications that we're working on. So it really is first-class engineering, and it needs first-class engineering discipline and techniques and all that. So the ideal Gradle scripting front end would make all of that possible. Okay, so how does Kotlin measure up to that standard? You guys will be the judge of that, right? But this is, again, some of the thinking that we were going into as we tried to answer this for ourselves. So is Kotlin richly expressive and fluid and readable and concise and declarative? Well, like you saw in Dimitri's talk this morning, when you put together all of these language features, like, of course, it has lambda expressions, but it has lambda expressions without parentheses if you don't want them. It has this idea of custom receivers, like Dimitri was talking about, and we'll see some examples of that allow you to have really concise, really expressive, blocks that you open up without having to say it dot and so on and so forth. Extension members, like extension functions and properties. First class support for delegation. So you don't have to, when you're implementing a kind of delegate pattern, you don't have to repeat getters and setters. You have a first-class language mechanism to delegate to another object, and we'll see examples of that. And of course, Kotlin has first-class scripting, and what I mean by that is that you can get rid of the ceremony, that you don't have to do a class declaration. you can just open up a blank file and start scripting, right? That's the difference between a .kt file, that would be like a Kotlin class typically, or interface, or some function declarations. That's a KT file versus a KTS file. And that's a Kotlin script, where in a Kotlin script, you're implicitly within the scope of some base class, but you're immediately just in a very ceremony-free kind of space. And that's, of course, what we want for Gradle, right? Gradle's model says when you're inside of a build.gradle file in Groovy land, or when you're inside of a build.gradle.kts in Kotlin land, you're in the context of a project object. So you're inside of a script, but there's a larger context, and Kotlin has a first-class mechanism for that. So it's very important for Gradle's approach to things. Okay, what about the other criteria? Is it highly performant? Is it tooling friendly? Well, we'll see, right? We'll see how it all plays out, and again, you'll be the judge, but it ticks a whole bunch of the boxes that make it likely to meet these needs, right? It's statically typed from the jump, through and through. What you have at the end of the day is a vanilla JVM execution model. Dimitri was mentioning this today too. So when you ask how does Kotlin perform, you're really answering the question, how does Kotlin perform at runtime anyway? You're asking the question, how does Java perform, right? How does the JVM perform? There's really no difference at runtime between the two. That's important. It has this idea of inline functions, right? So a first-class language feature that says, I'm declaring a function for the purpose of, proper modularity or decomposition of my application, but there's no extra bytecode involved. That inline function is going to be directly computed into the bytecode. So that's good for performance. And of course, coming from JetBrains, Kotlin's going to be deeply integrated with IDEA, but also with Eclipse, right? And there's, just recently releases, first releases of the Kotlin Eclipse support. The people on our BuildShip team have been getting into communication with the people doing that Eclipse support at JetBrains. And so we expect to see all the same kind of integration and cooperation that we've been having with the Kotlin team around IDEA with Eclipse too, and with BuildShip. Okay, and does Kotlin or can Kotlin take advantage of your existing skills and knowledge in all those different domains, tooling and language and patterns and techniques? Well, you definitely get to use the same tools, like we just mentioned, IDEA and Eclipse, right? And now, so how many people have used Kotlin at all? Fair number of hands, right? So now, at large, right, probably not a majority of people have used Kotlin, or at least not yet, but it makes it possible, it's conceivable. Like if you're an Android developer, you're probably already using Kotlin or already really wanting to use Kotlin. So if you're an Android developer, it becomes really possible to have the build script, build source, build plugins written in Kotlin, Android application written in Kotlin with no compromise. Like that's what they would want to do, and they can. For everybody else writing a web app or what have you, you might not be writing it in Kotlin yet, but by the time you get a lot of experience with it at the Gradle level and you see just how interoperable it is with Java, and if you decide you like the language, there's no reason that that web app or whatever it is that you're working on couldn't be written in Kotlin. So it's certainly possible to take advantage. Even though you're learning a new language, it would, as you build those skills, right, Gradle build scripts written in Kotlin would take advantage of your growing expertise with Kotlin. So in terms of, on the language front as well, it's a big selling point of Kotlin is it's 100% interoperable with Java. And the more exposure you have to Kotlin, you realize how legitimate a promise that actually is. It really is complete, this interoperability. And it shows. A lot of care has been given to that. So your familiarity with your expectations around Java, there's always an answer. How do I get this done? Or how do I consume this thing that I wrote in Kotlin from a Java context? I wrote a Gradle plugin in Java. How do I consume it from a Kotlin Gradle build script? Vice versa. It really works out. Right, and so because Kotlin is statically typed, and because it has deep tooling integration, you can take advantage of your knowledge about just standard engineering practices like refactoring and things like that. There's no reason that we couldn't or shouldn't be doing all of the same stuff we do in application land in the build. And of course, you can use the same standard libraries from Java. You can use the same third-party libraries from Java in Kotlin, naturally. So I want to talk about a few of the key design constraints now. Again, kind of on the principles tip, like what are we, even if Kotlin were a perfect Gradle build scripting language, and of course there's no such thing, nothing's going to be perfect, everything has compromises, but even if it was perfect, it's not in a vacuum. Gradle's been around for years. There's lots of concerns to think about as we make any change like this. And the first and foremost among them is the giant plugin ecosystem. So 800 plus plugins out there. The prime directive is make sure they work when you're writing a Kotlin build script. So will every single one of them work? Well, that would be a tough promise, but they'd better mostly work. And as we find, any that don't, that's a high priority for us. If they're using, if plugins are using certain dynamic groovy techniques or something that doesn't work from a Kotlin context, we want to know about that. That's a place where you can give us feedback. We'd love to hear it. We haven't seen any showstoppers there yet, but that's something that we're constantly keeping our eye on. The second thing is no magic, right? As an aspiration, as a directive, be as understandable to users as possible, assuming that you know Kotlin. You've learned the basics of the language, and assuming that you know the fundamental model for Gradle, right? You understand things like that you're within the context of a project object and so on. Once you have those kind of basic programming language and programming model aspects in mind, we want there to be no other magic involved, right? Like AST transforms in Groovy are a great thing. They're an amazing thing, but they're not the easiest thing for the average sort of build user to understand. So this is just one example, not to pick on anything there, but it's an example of what some people would call magic if they don't understand that mechanism very deeply. And I'm not sure it's fair to expect people to understand that particular mechanism very deeply. So, or things like, dynamic method routing or method missing or what have you. It would be good, it would be great if we could avoid that kind of so-called magic. And that's also very important, not just for the sort of cognitive model for users, but for tooling itself. Of course, the tooling needs to be able to have an absolutely complete understanding of what's going on in order to provide the richest auto-completion experience, et cetera. Okay, and then the third constraint is while we're preserving compatibility with all the plugins and so on, we also want to keep in mind, what does a future look like? If this all goes well and people are increasingly enjoying using Kotlin to write Gradle build scripts and decide that they want to do that, and they also decide that they want to write their plugins in Kotlin, what does a future look like that fully takes advantage of Kotlin? Not just preserves the existing compatibility, but like, what would it look like if people were writing plugins in Kotlin and being able to take advantage of Kotlin language features? What if people could contribute extension functions from their Gradle plugins? What would be the implications of that? And I don't mean to go into all of the details, the answers of that, but the point is we want to keep that in mind and make sure that we can sort of pave this path toward an idiomatic Kotlin future, if you will. A future in which somebody who knows Kotlin really well, let's say, starts using Gradle, they would say, oh, Gradle does things in a way that makes sense to me as a Kotlin user, and I can fully take advantage of Kotlin within Gradle as I'm writing my build scripts and plugins. Right, so those are a few of the constraints that are driving us. And now I want to talk about some of the challenges, right? We're very early in this process, just 0.20, version 0.2.0. We're on the road to 1.0, right? So that's something to keep in mind if you haven't gotten that point yet. We're shipping this with Gradle 3.0, but when Gradle 3.0 goes final, the version of Gradle script Kotlin that's within it itself won't be final. Right? We're doing that because we want to get it in the hands of as many people as we can, but we're keeping that 0 dot versioning to make it really clear this is pre-release. Anything can change. Things will change, right? So we're clearly advertising our backward compatibility guarantees or lack of compatibility guarantees until we go 1.0. But as Hans mentioned, we also have a pretty accelerated path, like an ambitious path to 1.0. We want to ship by the end of the year. So I want to talk about some of the challenges that we're currently dealing with on that path to 1.0. And one is just moving from a fundamentally dynamic world to a static world. And if you just take the very familiar example of applying the Java plugin and then working with source sets, declaring source sets, or customizing the default source sets like the Java source set. So what actually happens when you apply the Java plugin? Well, under the covers, the Java plugin has an apply method, right, that gets invoked. And as that's getting processed and as it's getting handled, it contributes dynamically some source sets, right? If you didn't apply plugin Java, the Java source set wouldn't exist, right? It wouldn't be available. This script wouldn't run properly. You'd get an error. So the word dynamic can mean different things here, but the meaning of the word dynamic that I have is that the presence of that source set is dynamic based on whether you applied the Java plugin. So what does it mean in a statically typed language and context like Kotlin to make available something like source sets? Like even if we make the DSL look exactly like what you see here, just having something statically available, having source sets available and being able to navigate to it and being able to get documentation on it and so on, doesn't mean that it's safe, right? Because in Kotlin, if you didn't apply the Java plugin, well, those source sets still aren't going to be available. So how do we square this circle? How do we make things runtime safe? Not just compile time safe. Compile time safety is the easy part. Kotlin just does that. That's its nature, right? But how do we make things runtime safe? So I'll give you another example of this, just to illustrate. How many people followed the 0.1.0 or what we were calling 1.0 milestone 1 of the Kotlin work? How many saw this string-based dependency configuration? Yeah, that was something that just a few people, right? But I'll still explain it. So usually when you're writing a Groovy-based Gradle build script, you would have a block that looks just like that dependencies block, but test compile wouldn't be in a string, right? It would just be a symbol like anything else. It looks like you're calling a method, right, or a function. We didn't do that in the first version, in the first pre-release version of Gradle script Kotlin, because we wanted almost like a note to ourselves to say, hey, that thing test compile, even if you make a method for it, even if you make something statically available, it really is, at the end of the day, a named thing. It really is, at the end of the day, just a string. It's a named dependency configuration. We talk about named domain object containers in Gradle, and that's one of them. So if the user doesn't apply plugin Java, and they come along and they try to declare a test compile dependency configuration, that's not going to go well. And so we made it string-based as a kind of, like I said, note to ourselves. We need to think more about this. We need to come back and find a proper solution to this. And in 0.2.0, in the latest pre-release, we've taken the next step. We've made it more convenient. Still not a complete solution. We've made available an extension function, test compile, an extension function called compile, right, for all of the typical dependency configurations, the ones that you get out of the Java plugin. We've done that for convenience. That was like the #1 complaint that people had when we did the first pre-releases. What's this string-based thing? So yeah, we've made it available, but it's still not a complete solution. This is why it's a challenge. Just to see what's on the other side of it, like what does that declaration look like? This is what, again, an extension function looks like in Kotlin. We're saying that there's this function called test compile, where you can think of it as contributing it to the dependency handler type, right? We're extending the dependency handler type. But look at what happens underneath. The implementation of that function adds a named thing, right? It's still just a string. So the challenge is how, if we can, we're thinking about different ways to do it, but how can we square the circle so that test compile is a statically available thing, a function, right, that you can get auto-completion for and so on, but only becomes available if and when you apply the Java plugin. And if you don't apply the Java plugin, test compile in that second screenshot is red, right? Test compile doesn't compile, right? That's the goal. And we can do it, right? There are ways that we can do it. We're evaluating different ways that we can do it. One of the ways, right, actually, if you look very closely at that third screenshot, and you look at the breadcrumb trail, it says source generated Kotlin, right? And that's inside of the Gradle script Kotlin code base. That's actually generated code. But it's code that we always generate. So when we build Gradle script Kotlin, when we're putting together a release or what have you, it's always there. And so it's always available to you as a user when you're writing a Kotlin-based build script. But what if we became dynamic about when we generate static code? So we could get smarter, and we could say, only when the user applies the Java plugin, then do we generate this test compile extension function for that user's project. This is one way that we could do it. Might be a terrible idea, might be a brilliant idea, right? We just haven't tried it yet. But just to give you a sense of some of the challenges that are inherent. Because at the end of the day, Gradle has a kind of fundamental dynamism to it. You may or may not apply certain plugins. And if you do, certain things become available. We have to accommodate that in some way. So another challenge is there are certain things that are common in the Gradle API, like methods that accept Gradle's action interface, or that accept Groovy's closure interface. And action is, like Dimitri was talking about this morning, one of these SAM types, single abstract method types. And so it's very friendly with Lambda expression, in a Lambda expression context. That's very handy, but it turns out, actually, that when you're writing a Kotlin-based Gradle build script, you actually don't want to use either one of these. Probably just makes sense that you don't want to use Groovy's closure interface inside of a Kotlin-based build script. But you actually also don't want to use Gradle's action interface. I'll say why in a second. One little problem that comes up is that you now have a bunch of things in the auto-completion context, neither one of which you want to use, but now you're finding yourself sorting amongst them. Like when we did our demo in yesterday's keynote, you might have noticed that sometimes when we were doing auto-completion, there's like a lot of stuff there, a lot of similarly named methods. So that's a challenge. It would be nice if these two didn't show up at all, because you don't actually want to use them, and the reason why is that you want to avoid the dreaded it problem. All right, so what is the dreaded it problem? It's that, right? Nothing wrong with this code. This is a perfectly reasonable code to write. Kotlin made decisions about having it as the receiver here, but in a DSL context, right, where you're trying to be as fluid and readable and concise as possible, and you're also trying to preserve things looking the way that they look in today's Gradle build scripts, we definitely don't want this it there. And that's just the way Kotlin works. So if I'm calling the copy spec function, and the copy spec function accepts a SAM type, action, that's what's getting resolved. So I'm calling the action variant of copy spec, or the action overload of copy spec. And it's just the rule. I have to qualify things with it. That's the way Kotlin works. But we don't want to, right? So the solution should be an extension function. Kotlin also accommodates this. Kotlin is like waiting for this situation and has a lovely solution for it. Should be possible for us in Gradle script Kotlin, right, to contribute a copy spec extension function that says, OK, take this custom receiver, that copy spec.parens, make copy spec the receiver of all calls that happen inside of that Lambda expression. That would allow us to get rid of the it. right? So when I call from and I call include, I would be calling it directly against copy spec, and it would feel exactly like the Gradle you know. It would indeed be identical syntax except for the val. There's just one problem. There's a precedence issue in the way that Kotlin resolves methods today, currently. This is the challenge part, right? Is that extension functions, like that one that we would contribute, have a lower precedence than member functions. So the action accepting copy spec that's actually declared inside the project type, that's a member function. And it has higher precedence than the extension function that we would contribute. So we lose, right? So we just can't do it. So if you're working with a copy spec in a Kotlin-based Gradle build script right now, you have the it problem. And we're just sorting that out, right? There are potential solutions. There's a number of them. One thing that we could do is we could actually just remove the overloads. We could remove the action and closure accepting methods from Gradle itself. We could deprecate them and then get rid of them, wherever that actually makes sense to do. But that's a bit destructive. That might take a while, too, to go through that kind of deprecation cycle. So that would be the actually remove the problem solution. And then our copy spec extension function would take precedence. It would be the only one, and we'd win. We'd get rid of the it problem. The second possible solution is that we could effectively remove those overloads by simply post-processing the Gradle API jar. When you're working from a Kotlin-based build script, we could just remove the action and closure-based variants, making it still so that our copy spec variant wins. The other thing we could do is just continue working with the Kotlin team, which we are doing, and we could see about introducing some kind of mechanism for, maybe you'd call it preferred extensions, right? Having some way of influencing the resolution process. And another thing that we can do on the whole point of things getting noisy in the auto-completion context is that we can work with the idea team to see about hiding those or somehow pushing them down or giving more context about what you probably want. So we're thinking about all those things. But like I said, ongoing challenge that we don't have a perfect answer to yet. So one other challenge is self-referential build script. What I mean by that is, again, nothing different than the Gradle that you know today, is that when you declare a build script block and you add something to the build script class path, in this case, our greeter plugin that we did yesterday, that we worked with in demo yesterday. If you think about what's actually happening under the hood, as that build script is being processed, there's this kind of cyclic thing that happens. Well, I need to get that plugin on my class path so that I can actually handle the rest of the build script. And that might not have been so obvious to you working with Gradle in the past because you didn't actually have auto-completion available to you. But it's a kind of magic thing. Like, how can I type class path, add the greeter plugin, and then 2 lines later automatically start working with the types from that plugin and getting auto-completion from them? Well, the way that we do this was a challenge. This is a challenge that we've solved, right? Is that we just have a 2-pass approach. This is what Gradle does in Groovy land too, but we had to do it in Kotlin as well. We have a 2-pass approach to processing the build script, right? So we look for that build script block, we compile it on its own, we resolve those dependencies, we create a class path, and then we process the rest of the build script with that class path. It's just, the amazing thing is, and you might have noticed this in the demo yesterday, is that it actually just all happens on save, right? When you save that file, dependencies are resolved, everything becomes available, and then you can immediately autocomplete stuff after that, which is a nice effect. And then a final challenge that I'll mention, certainly not the only other challenge, but just worth mentioning here is, of course, the challenge of maintaining multiple front ends or multiple scripting approaches to Gradle, right? So, for example, right now, things continue to progress in Groovy land and will continue to do so. Like maybe some of you have seen the work that we've been calling stable plugins DSL, right? Evolving the plugins DSL to be really fully production ready and fully capable and handle all the corner cases around the plugins block in the Gradle build script. So all that work has been done on the Groovy side, and now we play catch up. Now we have to make sure that we're feature compatible with them and so on. So that will be an ongoing thing, and there's just that ongoing maintenance that we need to do two things now where we were doing one thing, and that's naturally a challenge. And sort of part of that is preserving Gradle idioms. So there's a way of doing things that you're familiar with in Groovy and in Gradle build scripts today, and we don't want to have you unnecessarily or for no good reason have to do it a very different way, right? So things like declaring tasks and applying plugins and so on, that had better not be very, very different when you're in a Kotlin context or when you're in a Kotlin build script. That would be painful, and you don't want to have to relearn everything. It makes sense you have to learn some new language syntax, that's no problem. But you shouldn't have to leave the Gradle idioms that you know and that there are no problem with. You shouldn't have to leave those behind. And of course, we want to make sure that it's easy to migrate between things and it's easy to partially migrate between things. So like one place where you see that showing up, even in the very first pre-release, was that when you say apply from some script, you've always been able to do that in Gradle. Today you can say apply from, like if you're in a build.gradle that's Groovy based, you can say apply from and point at a Kotlin script. And if you're in a Kotlin script, you can say apply from and point to a Groovy based script. So in this way, we allow for sort of stepwise, piecewise, partial migration between those two front ends. Okay, so let's just talk about those. So those are some of the challenges. Let's talk about some of the features of Kotlin. Again, many of the things you saw this morning in Dimitri's talk. But how do we actually put them to use in what we're doing in Gradle script Kotlin? So one thing is this business of extension properties, and you saw a couple of those so far. Here's, again, the dependency configurations. That bottom declaration is an extension function for the compile dependency configuration. And we use these extension functions, extension properties, right? Altogether, we call them extension members, for convenient access, right? Convenient access to common dependency configurations in this case, and to make sure that IDEA can suggest available dependency configurations in auto-completion contexts. It's very handy. And so we use this, like I think Dimitri said, if you look at the code base, you'll see a lot of extension functions. That's not most, but quite a bit of what the code base actually is in Gradle script Kotlin. So we use these Lambda expressions, or function literals, as Kotlin calls them, with custom receivers. And it just makes possible that kind of syntax that you see at the bottom. Again, at the bottom, we're not saying it.testCompile. We just say testCompile. That's made possible by these custom receivers. And we use delegation, delegated interfaces. This just allows us, like in this case, repository handler is a Gradle API type. It's always been around for a long time. Now we have this Kotlin repository handler. And we just want to tune and tailor and do just a little bit something different with the repository handler interface. But everything else that's a vanilla repository handler, we want to delegate it to a repository handler. We don't want to have to redeclare all of the methods, all of the getters and setters and so on. So this is just taking advantage of Kotlin's first-class approach to delegation. It's the by, right? I'm this class called Kotlin repository handler. I accept a repository handler object. I accept, as a part of my constructor, something that is a repository handler. And I implement the repository handler interface by delegating to that object, right? So anything that's a repository handler method that I don't declare something for myself here, just hand it to that object, delegate it to that object. Very, very nice language feature. And same thing with delegated properties, right? So that was a delegated function, but also delegated properties. And we saw this in the demo yesterday where we declared a Kotlin property, a Kotlin delegated property that ultimately goes and resolves a Gradle project property. Okay, so I just want to talk a bit about how this has really been a process of co-evolution between the Kotlin team and the Gradle team. Of course, we're mostly consumers of what the Kotlin team has on offer, right? We're using their APIs and we're plugging into stuff that they've already made available and already anticipated. But of course, not everything has been anticipated. So there's been a lot of influence. It's not just been a one-way street. It's been a two-way street. And one example of that is the mechanism by which we inform the Kotlin scripting engine about the context of a Gradle build. So like I was saying before, when you're writing a Gradle build script, you're implicitly in the context of a Gradle project object. So how do we make the Kotlin scripting engine know that? Well, what we ended up sort of co-evolving here was this script dependencies. One aspect of this is that we co-evolved is the script dependencies resolver interface, a service provider interface. You can see that's being provided by Kotlin, right? Or JetBrains Kotlin script. And what that does is it provides a mechanism for, and it's a generic mechanism for any Kotlin script to advertise its dependencies, right? I'm a Kotlin script, and this is the stuff that I need, including things like implicit imports also get specified via this SPI. So we developed this for Gradle's purposes, but it's quite general. So now everybody can take advantage of this. And you can just see that at work here, right? So now we're on the Gradle script Kotlin side, implementing our Gradle Kotlin script dependencies resolver. And that all gets wired together in the Kotlin build script. So if you imagine that the build.gradle.kts script that you write, it has a base class, right? And that base class is Kotlin build script. And the way that the Kotlin scripting engine knows that is because of these annotations, right? The annotations, the script dependency resolver, is the glue that puts it all together. Okay, this is the base class for anything that's essentially star.kts. And how I figure out its dependencies and so on is via that implementation of the script dependencies resolver SPI. So just a nice interface between the two worlds. And just to show a bit more about that, look at that last parameter, the Kotlin script external dependencies. That accepts, like I said, what's my class path? What are my imports, my implicit imports? And you can see that on the Gradle script Kotlin side. That's where we actually advertise, hey, every build.gradle.kts always has these imports available to it, right? So you don't have the ceremony of saying or Gradle API plugins every single time. This right now is static. There's just those two packages. But something that we may want to do is open that up so that plugins, perhaps, maybe plugins want to come along and say, I'd like my imports to be implicit too. We haven't done that. Maybe we will, maybe we won't, but feedback would be interesting. Okay, and so that's just one example of the kind of interaction that we've been going through, and it's worth mentioning this the enhancement process for Kotlin. This is a place where essentially specs get put together and so on. It's very much like other language ecosystems that you might be familiar with, like JEPs in the Java world and so on. But you can see the echoes of what I was just talking about if you go visit that repository. And it's a nice, lightweight, simple process. Okay, so let's talk a bit about roadmap. There's many things we could talk about here, but like I mentioned, catching up with the plugins DSL. Since that's just finishing up, we want to make sure that we have feature parity with it. Like what I was talking about with the action methods and getting rid of the it problem, we want to make sure we have a consistent single approach to that, so you're not having to do little one-offs and workarounds. Performance, right? Compilation speed. This is partially a Kotlin thing. Like Kotlin is working on performance, will continue to work on performance of its compiler, for sure. But there's also script caching, right? Caching may be on the Kotlin side, caching on our side. Now that the daemon's on by default, actually things are pretty fast. Yeah, you probably don't notice a big difference with Gradle, but we want things to be as fast as they possibly can. So that's definitely on the radar. Support for build source. We don't have first-class support for writing your build sources in Kotlin yet. And we don't yet support writing settings.gradle in Kotlin. But it can all be done. These are things that we think about, in a pre-1.0 context. Automatic detection of build.gradle.kts. And what that means right now is there's this little workaround that you have to do right now. If you want to work with Kotlin-based build scripts, you actually have to write a settings.gradle that specifies the name of your build script that tells Gradle, hey, my build script is actually this build.gradle.kts. You have to say that in settings.gradle. And that's the bootstrap mechanism that makes it all work. But of course, we want to make it just work out of the gate so that you need nothing more than build.gradle.kts, that you don't even have to declare a settings.gradle. Other stuff that's on the docket, a modular upgrade mechanism. You may have noticed that Gradle script Kotlin doesn't actually live inside of the Gradle repository in GitHub. It lives on its own. It lives in its own repository called Gradle script Kotlin. And that's what allows us to have our own independent versioning and to put together these roadmaps and have very well-defined timelines and our own release notes and our own community and stuff like that. That's all a big win. But of course, it's necessary to make sure that when we ship a new version or we ship a patch, right, we fix a little bug, we don't want you, the user, to have to wait for the next Gradle distribution release train to ship, which might be 1 or 2 or 3 weeks away. So we want to make sure we have an upgrade mechanism for this little module called Gradle script Kotlin that allows you to say, hey, I'm using Gradle 3.0 or 3.0 milestone 2, but I want to upgrade to Gradle script Kotlin version 0.2.1 or whatever it is. And that mechanism will be very useful because there will be other parts of Gradle that become increasingly modular. And it'll be nice to be able to upgrade to just the very latest release, try things out, try out snapshot versions or what have you, without having to wait for a new Gradle release. I'm going to skip the rest of that just for time, so we have time for a question or two. But the point is that that roadmap is very much dynamic and underway. And as we finish up the summit here, we'll regroup to plan version 0.3.0. And you can influence that, right? It's all on GitHub, just like you would expect with any open source project. So you can go visit that. What you might not notice, if you're not careful, is that our issues, it's just GitHub issues, but we're using ZenHub as well. Anybody familiar with ZenHub? Just curious how many people have used it. Check it out. If you use GitHub issues, and especially if you manage a project, you might want to check this out. It layers a Kanban board on top of GitHub, and it does it inside the GitHub UI. You just have to install a browser plugin. And we've been using this really extensively inside of Gradle lately. It's been pretty effective. So you can check that out, right? And it helps if you actually install the plugin because you can really see our workflow as we go through stuff. But add issues, use ZenHub, don't use ZenHub, doesn't really matter. But come talk to us about stuff. And one place that you can talk to us about stuff is in Slack, in Kotlin's public Slack instance. I'll have a link that shows you how to sign up to that at the end if you like. But you can see highlighted down in the corner. It's really amazing how vibrant the community is in that Slack instance. I just looked this morning, like even just a month or so ago, there was like 2,000 users in there, and now it's like 3,300 users. And a huge number of Android developers in there. Like there's a lot of people, chatting about Kotlin and dozens of channels in there every day. And one of those now is the Gradle channel. And like you can see, there's like a couple of hundred people that hang out there, and we get great feedback there. And we'd love it if you come and hang out and do the same, if you're interested in all of this. So with that, I just want to say a quick thanks, especially to the team at JetBrains. Can you just wave your hands? Probably seen them around anyway, but yeah, thanks so much. It's been really like fun doing it, and I was telling those guys we should have a conference every week because we got so much done in the last week preparing for this. People up at 1 a.m. in Russia and other places. It's really appreciated. And to all the people who have been participating in any way in the Gradle Slack, in GitHub, we've got a little burgeoning community, and it's been great. So with that, yeah, some links. That's the repository. That's the link to sign up for the Slack channel if you like. And come and ask questions. Thank you. I think we're right at time for the break, but could do like one question, 2 questions if you like. Yeah, go ahead.
You already mentioned Kotlin testing frameworks and plugin testing with Kotlin.
Yeah, like in general?
Yeah, I mean in terms of guidelines, whatever. All the documentation, I haven't seen anything about testing
Yeah, well, yeah, so the question is, what about Kotlin testing frameworks? Spec is one that's out there, SPEK. So you can check it out. We used it quite a bit. We also just use JUnit. Like, actually, JUnit gets a lot nicer to use when you're using Kotlin for a few reasons. I'd be happy to talk to you about it afterward, but I'm also just not really an expert on it. So, yeah. Anything else? No, OK. But questions welcome afterward. Thanks again. Cheers.